Introducing BuildSafe. So BuildSafe lets you build tamper-proof builds and eliminate your CVE fatigue, creating a secure software supply chain, helping you reach the SLSA provenance, and making security easy, shifting it to the left, searching for the packages, all using the underlying technology of Nix without any complexities that you need to know about Nix. And in this tutorial, we'll dive deep into how you can actually use it for a particular project and some of its core features. So let's get started. So this is buildsafe.dev, and it's basically a GUI that lets you browse the OS dependencies, and configuration syntax is pretty simple, and it also is compliant with the high quality SBOMs and provenance on the build. So all the features that you get as developers and not the security teams do not have to do the heavy lifting for it. So there is a Killer Coda playground for this, which already has Nix installed. So it has nothing installed, just Nix installed over here. And the next thing we are going to do is try to actually use this for a Golang application. So we'll install BuildSafe first. So you can install BuildSafe using Nix itself. So the simple command is Nix profile install GitHub BuildSafe dev/BSF. And then we'll clone this example, cd examples go. So this is simple main.go, which is handling different function calls. You can see that over here, and each of them have their own respective logic. Pretty simple app, and it has a HTML file. Now what the first step in BuildSafe is to do a BSF init. So we do BSF init. So this usually takes some time because it's making out the Nix files and downloading the dependencies, caching them. So it usually takes time for the first time when it runs a minute or two. So as this is complete, what we can see is it has created a few files and directories. So first it has generated bsf.hcl file, which is the structure of application where it has the development dependencies like the compilers and stuff required to build the application, and in some of the languages linters as well. And then the runtime one, which are required to run the application in production. So it's basically capturing both from development to production. Then the Go module, and that's pretty much it for this particular file. Then you have BSF lock that locks all the dependencies, version, and some of the additional metadata that is later on used on generating the SBOM JSON files. Then you have a BSF directory. So let's move into that, and we'll see some of the Nix files. So you have first the flake.nix file that has the where we download the OS dependencies, the OS packages. So it is stored in this particular file. And then you have flake.lock, and then you have default.nix where you have some of the compiler flags and all those stuff goes in here. And then you have go mod to Nix file. If you have any dependencies, their hashes will be stored in this particular file. So these are the files that get generated when you do the BSF init. And like I said, BSF is a TUI. So you can just see, okay, this is BSF. It opens up a TUI, and you can go to each of the command and see, what is actually happening. Like this will give you the command. Now the next step to be done here is BSF build. So this is building the application. So it's your simple Go application that you are building, and it is using Nix under the hood. But you don't have to care about knowing the Nix stuff, the flake files, and how to do that. And now it has generated the artifacts. So we can see that there is a directory called BSF result, which has been created. And if we go /result bin go server, you can see it is running on port 8080. And if you just go onto the port 8080 in Killer Coda 8080, just to see our application is running, you can see the simple app. You can add the name, you can delete the name, and you can add BuildSafe and stuff. And that's the simple API calls that is happening. So now what we are going to do is, we have seen the buildsafe.hcl file. We will try to add a package. So one thing to note over here is we have the bsf.hcl file. Let's say you want to develop. So developing is what the developers do. And while developing, they are adding the packages that they need to get their work done. And for example, you need curl package. So how you used to do that in the Docker files, you just need to download the curl package and it would come in the container. So here you have like 94,000 packages plus in the Nix, and you can do that. Now, we don't want you to kind of go away and search the package and get the exact version. You need not know that. So what you need to do is BSF search curl. So what it did, it tried to search curl, and we are seeing more number of packages because it does the search based on curl, the package name, also what their maintainers have created other packages. So you are able to see all the other packages. You can also filter it down like slash and give a grpc, so you can see you can filter it as well. So for example, if now you need curl, you select it. This is where things get interesting, because it gives you curl with all the versions which are available, license, if it is free to use or not, and the home page. Now as a developer, I can easily check, okay, if it's 1811 and if I select it, wow, now I'm able to see the CVE versions. So I'm able to see a CVE version attached with this particular curl version. I do not have to kind of go or give this to security team for further review and I use whatever I feel is right. I can exactly choose the version which do not have the vulnerabilities and choose a specific version, for example 871, which says that it has 0 vulnerabilities found for curl 871. So that's where, as a developer, I can easily choose the right version with 0 CVEs for my development, and this will lead to a 0 CVE fatigue application when it gets into the production stage, because the stuff that you have used is already CVE free. So now you know what you are using and what goes inside the application. So this is the, bringing out security to the left and with ease. Like, you don't have to know all these things, but it's easy. So let's say for now, what we do is we select this particular version and we add it to the development. So for selecting its space, so we add it to the development version, and we allow the minor version patch update. So you can actually allow the updates for your application, and we'll do the update as well, which is pretty cool. Now let's see the bsf.hcl file. You can see curl 811. This particular version is added. And now what we can do is, in order to create a development environment for the developers to develop the application, there is a command called bsf develop. So we are now into the development shell, and if we do curl-v, we'll be able to see it's 811. That's the development shell. And what we can now do is, we can now do a bsf update. So what this is, this updates the dependencies to the higher versions. So let's do a bsf update. It is updating the packages and the update ran successfully. And if now I do cat of bsf.hcl file, we can see the curl version to 871, which was the latest one without CVEs. That's the ease of how you can actually search for a package, add that package to your development or runtime environment, and add auto updates. There can be some, Dependabot kind of bot as well that can be built, and it can raise PRs just like Dependabot does for the runtime packages. It can do for the language packages. It can do for the OS packages which are required, and raise the pull requests. So those automations can be easily done. And now if we do a bsf develop and we do curl-v, we'll be able to see the 871 version of the curl which is updated. So that is the power. Let's move on. So like I said, BSF also takes care of attestation, or the SBOM generation per se, with additional metadata. So if we go to the BSF result folder, there is a new file called attestations.into2.json file which gets created. So now what you can do is BSS ATT-ls add attestation. So you can see that there is a SPDX, Cyclone, and the SLSA provenance. So all these are available. So we can also run BSF ATT cat, this particular JSON, and predicate type SPDX and predicate. So we'll be getting the SPDX format of SBOM, which is there, which is pretty cool. And now what we can use is, we can use any of the scanners out there to check the vulnerabilities in this particular SBOMs. For example, let's say Trivi, we use Trivi. So we will first install Trivi. So first let's put this into sbom.json. And now since we have become Nix fans, we'll do a Nix run, Nix packages Trivi and --sbom, and we'll pass this particular sbom.json file to see if there is any vulnerability or not. Hopefully there shouldn't be any vulnerabilities for this particular package or this particular application that we have built. And you can see the number is 0. there is no detected vulnerability, and it has detected the SBOM format. So like this, you can generate the SBOMs in SPDX Cyclone with all the additional information that we captured for the OS dependencies. So this also adds a lot of value within the Nix ecosystem, and how you can, on the developer side of things, how you can actually do the supply chain security right. So you did the vulnerability right, you did the supply chain security right, and you were able to shift security to the left. Now the next step is to build an OCI artifact. So suppose we want to build an OCI artifact, we can do that using BuildSafe itself. We can define multiple OCI artifacts within the BuildSafe.hcl file for the configuration of our application. And let's do that for one of the OCI artifact that we want to do. So vi bsf.hcl, and in the blocks, we add an OCI block. So OCI dev, so let's name it dev. And in the name, we give the repo name, for example, ttl.sh anonymous, fine. And in the CMD here, we define what all commands, the entry point that has to be given. So that can be defined over here. Save this. For building, it's bsf OCI, the dev block that we gave name, and -- load Docker. So it will load the image in the Docker, and then we'll be able to use Docker to run this particular application as container. And obviously the first build usually takes time because none of the dependencies are present to build the OCI images. That's why it is kind of taking some time to build the image. Now you can see the image is built, so completed successfully, loaded into the Docker daemon and ttl.sh, BuildSafe go app dev. And now we can run docker run -p 8081 and 8080, the container port. Host port can be any. And then the app name. So it will start the server. And if we go in a new tab, we do curl localhost 8081/ping. It should return a pong, which it is doing. So our application is running via Docker as well. So we can see Docker PS, and our application is up and running. So that's how you can build an OCI artifact as well using BuildSafe. So this was BuildSafe. If you like the project interesting, make sure to check that out. Make sure to let us know any feedback that you have for this particular open source tool. It's open source. Please feel free to contribute. It's using the Nix ecosystem. So it's easing out Nix. It's easing out the supply chain security, streamlining all the 90,000 packages to search across the packages, the CVEs attached to those packages, so that you can use the right version for your particular application, and then build your apps and also export them as OCI artifacts so that they can run on any platform. There is no need for Docker files and stuff like that. It has support for Rust, JavaScript, Python, and Golang as of now. And we are open to adding more support and, taking this to further level. Make sure to raise issues, demand anything that you need so that this can be taken to the next level. Get involved in the project and give us more and more feedback, because next set, it has to be a feedback-driven development after the POC has been released. I hope there is some excitement about the supply chain security in the Nix ecosystem, and this solves some of the issues that we have seen. Thank you so much for watching the video. Make sure to join Discord and share about BuildSafe in your network.